Yeah, good afternoon, honey. Yeah, I'm fine. Thank you. How are you? Can you hear me? Yeah, if you have any question, you ask. Okay. Can you hear me? Honey, can you hear me? Okay. Now your question is what is magnetic aptitude in bare? Say in bare vinegar oxidation, what happens is there is a 3-center 2-electron bond, because on the say for example you have a peracetate or perbenzoate that is attached to a ketone. That means there is, on the ketonic carbon, there is one OH group and the peroxy. That means OOCOR. If it is a peracetate, then OOCOCH3 or something like that. Now, what happens is in bare-Veliger oxidation is that from the peracetate part, the acetate or benzoate, whatever that peracid part is, of that, the acetate or the benzoate part and positive charge on the oxygen. That means since it is a per ester, there are two oxygens attached to a COCH3 or CO phenyl, whatever it is. So basically delta, there is a delta negative charge on the OCOR part of the peroxy ester, and there is a delta positive which is attached to the on the oxygen, which is directly attached to the carbon, which also holds OH group. And then what happens, the one of the two groups, which is of the ketone, carbon-carbon bond or whatever, that migrates to the oxygen which is having delta positive. And of course, the acetate or the benzoate goes off. Now, as a result, there will be now migration. So there will be a positive charge on the carbon that holds the OH group as well as the perester group. And therefore, the OH group goes back to the positive charge, and the OH bond breaks and goes to the positive, and then you get COO, whatever the group has migrated. Now, in this migration, now if there in the ketone, if there are two different groups, R and R1, for example, and it depends upon which group will migrate. Now, how does that happen? Like for example, when you have a delta positive, as I told you that the delta positive takes place because there is a delta negative on the acetate or a benzoate part. Means a charge on the oxygen, and therefore, if the bond either R or R1, the group R or R1, when it migrates, is basically migrating to satisfy the positive charge which is there on the oxygen. That means the R1 or R, whichever group is migrating, is attached to R, of course, the carbon on which that R1 is there, and also the carbon on which the OH group is there, and also the positive charge on the oxygen. That means this carbon holding the OH group, oxygen, and the R1 group, all the three are basically sharing the positive charge. And therefore, the group that migrates is the one that migrates which can satisfy the positive charge. That means electron donating group will migrate because it has to satisfy the positive charge. In the transition state, basically, it is going to be a three-center, two-electron transition state having a positive charge, and therefore the group that migrates should have an electron donating ability. Is it clear? Sometimes to do epoxidation, sometimes we use H2O2 with base. Yeah. See, for the epoxidation of an electron-rich double bond, we use peracid. Why do we use peracid? Because when you use a peracid, say metachlorobenzoic acid, you have already, as I mentioned, there is a delta minus on the peroxy, that is ester part, which is going, like for example, OH, OCOR, or metachloro, whatever, benzene. So OCOR is having delta negative. That means this metachlorobenzoic acid is the source of OH plus, basically, which of course becomes kind of O plus finally. Therefore, electron-rich olefins should be able to react with metachlorobenzoic acid. On the other hand, if you take an alpha-beta unsaturated ketone or ester or any other alpha-beta unsaturated system, like for example sulfone or nitro or ester or cyano or a ketone, whatever, then the double bond is not electron-rich. Therefore, what you need is, when the reactions take place between a double bond and a peracid, the double bond is electron-rich and the peracid is electron-deficient. And therefore, the reaction takes place. because one behaves like a nucleophile, one behaves like an electrophile. But in the case of say alpha beta unsaturated system, hydrogen peroxide, when it is used with base, it forms OOH minus. That means O minus and OH. Now it behaves like a nucleophile. So when this acts onto the alpha beta unsaturated system, then what will happen is you will have a Michael reaction on the double bond, and finally when Michael reaction occurs, there is a negative charge which will be next to the ketone or ester or cyano, because Michael reaction of the OOH minus has occurred, and therefore the negative charge which is now next to the, say for example, cyano, that attacks again on this OOH oxygen, and OH minus goes as a leaving group. That is how the epoxidation takes place. So the difference between the two of them is, one is electron-rich olefin and electron-deficient metachlorobenzodic acid, and electron-deficient olefin and electron-rich OOH minus, which comes from hydrogen peroxide and base. I hope it is clear. Now quinoline, what is quinoline? Can you please explain the what is in the quinoline? Where is the Pelkin-Ahn model coming? I don't understand that. Unless you convert a quinoline, if alkene and ketone are both present, given when we put MCV, what will happen is epoxidation will take place or barrier oxidation will take place. Yeah, it's a good question. Generally, what happens is, if for bare vinegar oxidation, as you can see, that bare vinegar oxidation requires nucleophilic attack of the para acid to the ketone, whereas bare vinegar, this epoxidation requires nucleophilic attack of the olefin to the para acid. So the reverse role is there for each one of them. So when you do bare vinegar oxidation, you generally use either a base to initiate the nucleophilic attack of the OOH minus, or you add little bit of an acid. So what does acid do is, acid or any mild Lewis acid that activates the ketone. If that activates the ketone, then what will happen is that the electrophilicity of the ketonic carbon will increase, and therefore the nucleophilic part of the nucleophilic reaction of the per acid, because per acid as such is not a good nucleophile. So in order to make it reactive, in the case of bare vinegar oxidation, you need to increase the electrophilicity or of the carbonyl carbon, or you have to increase the nucleophilicity of the per acid. Therefore, either you use base to increase the nucleophilicity of the per acid, or you use acid or Lewis acid to increase the electrophilicity of the ketone. Otherwise, normally the reaction will give you this epoxidation. Now, in the case of quinoline, can you please talk about the stereochemistry of sharpless asymmetric dihydroxylation? How to prepare organic chemistry? Now, let's explain to you about quinoline. Who is quinoline? Is quinoline is a person, or what is it? Quinoline, honey, sir, can you please explain the Pelkin-Ahn? See, Pelkin-Ahn model is basically a slight variation of the Cram model. The only thing is that what you have to have is a 90 degrees this attachment there. So I really don't know how you want me to explain it without any model here right now. How to prepare organic chemistry for a great examination? Sir, can you please talk about the stereochemistry of sharpless asymmetric dihydroxylation? Okay. Sharpless asymmetric dihydroxylation, basically, as I mentioned in my classes, let me see if I can present that. to you. Let me see if I can present that. I have that possibly. Let me present that. Can you see the can you see the yeah, okay, fine. How to prepare organic? Now yeah, I'm sharing the screen. Can you see the screen? Uh, Whatever the name is. Honey, can you see the screen? Now you see there are the dihydroxylation takes place, as you can see from here, that this is the mnemonic device, which is little bit difficult to explain why this happens, because the model which has been presented by Sharpless is not very easy to explain, but mnemonic device helps you to get the stereochemistry of the dihydroxylation. As you can see that if you have, I hope you are able to see uh, that if the double bond is oriented in this particular fashion, so that in that particular rectangle you orient the large group, small group, medium group in this particular fashion, northwest, southwest, northeast and southeast, then if you use the uh, the this dihydroxylation reagent, then one of them, of course, that is uh, AD mix alpha, like as I showed in this particular case, AD mix alpha will give you the stereochemistry of the dihydroxy groups from the alpha side. Alpha side means from the bottom side. Whereas if you use AD mix beta, then it comes from the top. As I showed in this particular case, these are the various linkers and spacers which are used to the reagent that is presented. Now, this imparts, depending on the which kind of quinine is used, quinine or quinidine is used, the stereochemistry is decided accordingly. Since, as I said, that it is not easy to explain unless until I have a model and I bring it in front of you, you will not be able to understand exactly why it happens. But this is a mnemonic device which can be used for the predicting the stereochemistry. Now, how to prepare organic chemistry for GATE examination, which books are important? So, for that, I mentioned last time, there is no practice book as such. I don't think there is any practice book as such for the GATE examination and all that. You have to solve as many questions as many questions as possible from as many sources as they are available. But I can tell you that there are many books which towards the end, for example, this Carruthers book, the latest versions, there are many other organic chemistry books which have, but I would say that they are not really meant for gate exams or something like that, because when the questions are made in gate or whichever examination, competitive examinations are there, the the questions are prepared or made according to the knowledge of that particular teacher, and they refer to the topics that they are there. They don't really go and see the questions which are there. So I suggest that you should try to get old question papers, gate question papers, or any other question papers from various competitive exams and try to solve them. Then only it is possible. For this particular course, of course, as I said, that you have to go through the content very carefully. If you go through the content very carefully and assignments, I think you can also solve the gate examination papers. But otherwise, you have to look for various question papers which are already there. Now, what is the explanation of anomeric stability? Anomeric stability, see, the thing is that when there is an electron withdrawing group, for example, chloro or any other OR, any other OH group, etc., what is there is basically the antibonding orbital of that carbon, say, electron withdrawing group, which is alpha. Anomeric stability is basically means that the group which is present as an electron withdrawing group generally prefers to stay in the axial position at the anomeric carbon. Otherwise, normally in a cyclohexane system, the group prefers to be equatorial, that is beta oriented. In the case of this particular anomeric stability type of question, the electron withdrawing group prefers to stay in the axial position, because the anti-bonding orbital of that carbon electron withdrawing group now would be exactly pointing up opposite to the bonding orbital 180 degrees away, and that and the lone pair of electron on the oxygen of the ring, that is, say for example, if it is glucose, then the ring oxygen, one of the electron pairs on the oxygen, and this anti-bonding orbital which is empty. Now, since it is electron withdrawing group, therefore it is more empty, because all the electrons are being pulled towards that electron withdrawing group, and therefore there is a more tendency for the oxygen lone pair of electron to share its electrons with the antibonding orbital which is relatively electron deficient, and that causes the stability and preference of the anomeric carbon being alpha, or say axially oriented. I hope it is clear. Okay, so now Hani is suggesting that I should teach another course, new course of organic chemistry in upcoming. Actually, yes, I am thinking about that, or I may do that in future. Is there are many oxidation, reduction, and C-C bond forming topics I have not covered in this particular course. More on, say for example, more on chromium, or more on other lead and many other things, and also many C-C bond forming reactions. So yeah, thank you for suggesting. I will try and do that. Yes, yes. Because the lone pair of oxygen will try. No, see, what is happening is that they will try to stabilize the anti-bonding orbital of the anomeric carbon containing the groups like OMe. Yes, OMe is basically an electron withdrawing group, or any other OH group, or a chlorine group. So what will happen is that any electron withdrawing group will try to pull the electron density towards it in itself. As a result, at the anomeric carbon, the positive charge, there will be delta positive charge. Now, this delta positive charge would like to take electrons. Now, you say methoxy group is that it can give electrons, yes, but at the same time, the anomeric is the ring oxygen also will give its pair of electrons, and therefore it will stabilize. Other thing you can imagine like this, that you have an electron withdrawing group which is present at the aromatic carbon. Imagine that the group electron withdrawing group now, which is pulling electron density towards its side, is now is a beta oriented. That means equatorial. So now, if it is equatorial and electron withdrawing group is pulling electron density, that means electron density will be towards it, and that will have an interaction with the lone pair of electron on the ring oxygen, and that is not a favorable interaction. So it prefers to go to the actual position, because in the actual position it is very easy for it to avoid the electronic repulsion from the anomeric from the ring oxygen electrons, and also the antibonding orbital overlap. I hope it is clear. What is the best reagent for reduction of nitrobenzene to aniline? Okay, I mean, normally nitrobenzene to aniline is done by hydrogenation is much better, Raney nickel based hydrogenation or something like that. Lithium aluminum hydride cannot be used for this kind of aromatic nitro compounds. Generally, it is better to use either hydrogenation or something of that sort. Yeah, Sharmila, good afternoon. Questions? Please teach new course of organic chemistry in upcoming year. Okay. Any other question? Yeah, please ask questions. Yeah, please ask question. Okay, what type of reagents will give 1,2 and 1,4 addition? You see, you have to understand that the 1,2 addition, it means there is a 1,2 addition is basically means there is a hard nucleophile and hard electrophile. The carbonyl carbon is hard electrophile, and any hard nucleophile means the negative charge is concentrated, it is not delocalized, it is hard. Like for example, you have OH minus, cyanide, or say for example, you have Grignard reagent. These are all hard nucleophiles, and therefore such reagents will attack and give 1,2 addition product. On the other hand, 1,4 addition is given by soft nucleophiles. Soft nucleophiles are generally large in size. For example, SH minus or RS minus, that means phenyl S minus, or any other stabilized negative charge. For example, you have diethyl malonate, which is having a negative charge, and since because two ester groups are there, the negative charge gets stabilized. Therefore, such a nucleophile will be soft nucleophile, and that attaches the beta carbon of a alpha beta unsaturated system, because that is the softer center. Softer center because the positive charge is not as much as on the carbonyl carbon, because carbonyl carbon directly, because of the electron withdrawing nature of the oxygen, positive charge on the carbon of the carbonyl group is harder acid or harder electrophilic carbon. Therefore, the harder nucleophile attack there. It's acid base, hard, soft acid base, principle based, and therefore, because the carbon is of the carbonyl carbon is directly attached to the oxygen. But if it is alpha beta unsaturated system, that means that particular carbon atom is receiving electrons from the double bond, and therefore the positive charge at the end of the double bond on the other side is having less positive charge, and therefore it is soft in the media. That is all. Now I hope it is clear. What is the green alternative of potassium cyanide for forming nitriles for halides? Well, uh, it is difficult directly, but there are various ways of doing it. For example, if you take nitromethane and you add an anion of the nitromethane to the halide, that means you have any halide where there is a carbon that is attached to a bromine or iodine as a living element, and therefore now which nitromethane as an anion, then it will give you that particular carbon and CH2NO2. Now there are ways of converting CH2NO to the nitrile. This is one way. The other is acetone cyanohydrin, which is also made from potassium cyanide only by reaction with acetone, but acetone cyanohydrin can also be a useful reagent. The other is trimethyl silyl cyanide. That means instead of using potassium cyanide, you use trimethyl silyl. Trimethyl means Me3SiCN. This also acts like a source of cyano. I hope it is clear. Uh, honey, like sir, RMGX will give direct attack on carbonyl, and if we get put grignard with copper metal, it would prefer to attack on alpha. Yes, that is true. Now, what have you done is when you use copper salt, what you have made is what is known as Gilman reagent. That means now what you have is, say you take RMGX, so it becomes R2CuMgX. That means it is called, say, this dialkyl cuprate. Now because of the cuprate, now this particular path is large, big, and there it has become softer, and it then attack at the end of the double bond of an alpha beta unsaturated carbonyl compound. Why a brominated compound lacrimetric? Oh, well, not all brominated compounds are lacrimetric, but some of them are, where because I guess, for example, if you take phenyl bromide, it is lacrimetric. I don't really know exactly why it is lacrimetric, because it's entirely different chemistry. We don't know what that chemistry. Basically, it is a sensory. This your organs in our body which sense that. I suppose some of the compounds, brominated compounds, where HBr is relatively easily liberated, can become um, lacrimetric. So I suppose, like for example, phenyl bromide, phenyl COCH2Br. But why it is lacrimetric? It is, I think it's a very different chemistry altogether. Yes, you are right. Gilman reagent. That's what I meant. So actually, you can take any nucleophile RLI, RMGBr, or anything of that sort, and add cuprous salt, cuprous bromide or cuprous iodide. Of course, there are many other higher order cuprous copper cyanide is also used. They act bigger, as bigger in terms of electron, in terms of steric hindrance, and then they become better. I hope it is clear. No, 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 no. I am not teaching in IIT Bombay chemistry department. Actually, I was a professor of chemistry at IIT Kanpur. From there, I retired, and now I have shifted to Bombay. Um, I stay in Bombay after retirement, and I happen to record the lectures at IIT Bombay, and that is how I'm associated with IIT Bombay. No, I'm not teaching anymore now. I'm not associated with any. I'm retired from IIT Kanpur. Yeah, further questions? Okay. Uh, One of the most obnoxious reagent is diazomethane. Diazomethane is very difficult to handle, and it can explode if you are not very careful and temperature increases. CH2N2, and we used to make it, but it's also a wonderful reagent because it can acid to phosphorus. The other obnoxious reagent is also dimethyl dioxyrange, which I have taught. Obnoxious in the sense that it is uh, it will if the temperature is not maintained, it can explode also. Of course, then I have used osmium tetroxide, which is also supposed to be obnoxious, and of course, potassium cyanide also we have used it. So all these are plus. In addition to that, I have also used 90% hydrogen peroxide, which is also very difficult to handle. But that I used in America when I was studying in America. Uh, so these are the obnoxious reagents I'm handling. You told me that you are, yes. The I am writing the book, and it may take about a year or year and a half to complete the book. And I expect that that book should take care of the topics that I have covered and the topic that I want to cover on oxidation, reduction, and CC bond formation and rearrangements for future. And there I plan to bring out various questions as exercise for various kinds of competitive exams. I hope so. I am planning. Which university are you people studying? Can you tell? Honey, Quinoline, and who else is there? Sharmila. I do not know if they are there or not. Um, which in the book or in the you are talking about in the book? Yes. If it is the book, then I will cover all the topics. I mean, up to the MSc and maybe to some extent PhD level. The topics of oxidation, reduction, and CC bond formation with various examples and literature references, and possibly. So you that now. Okay. Yeah. So you people are now doing MSc somewhere? Chemistry honors. Okay. All right. So how did you find the particular this my course? Was it helpful? You are from two different and good universities, Delhi University and Calcutta University. So I would like to know your feedback. Did you like the course? Did you get to know new things? Okay, okay. Well, generally what happens is dichloromethane, chloroform, actually they evaporate very fast, and also there will be and therefore you get that feeling of cooling basically. It's not really burning sensation as such, but to some extent, of course, the chlorine will make a difference also. Now, can I go from this platform? Yes, sir. Anish, yes, sir. I connected with this platform from the last 3 years. Okay. So, my question was, did you get benefited from this particular course? And if you have any suggestion for improving this particular course? Yeah, that is true. Actually, I would have ideally liked to teach on board. Uh, Unfortunately, that is not possible on this particular forum, uh, because they gave me the Wacom board where I wrote on a board, and I was not able to. That is true. I taught in IIT Kanpur for more than 37 years, and I personally like to see the students as well as to be seen by the students. Okay, so you are not okay. Fine, Quinoline. Uh, I understand. You please go through and see whether you like it not. So you have to understand that the Teflon, of course, is a polymer, and I do not know why it is slippery, but that is a property. But why inert is because there is no functional group there that can get easily activated. What happens when particular material gets very reactive is basically oxidation in the nature, basically, and Teflon doesn't have oxidation to take. It's not that there are no functional groups. So the fluorine is a highly electron withdrawing group, and therefore any reaction there it cannot easily take place. That's the reason why it is. Teaching on board is far much greater than in compare of these electronic. Yes, I do agree with you totally, Annie. I agree with you. But there is absolutely right now I did not have any option to teach on the board which can be captured by the camera. I had this particular option on writing on Wacom board only. That's the reason why. Otherwise, yes, I do prefer the writing on the board to see the students and also to be seen. But that is not possible. In this particular forum, if I teach on the board, then it can be easily. Uh, no, I don't know anything about ONGC now because I never dealt with ONGC. But I know that they hire people have chemistry background. One of my first PhD students actually was long back in 1986. He was 85. He was given a job in ONGC, but he had an organic chemistry background. That's all. But I don't know anything more than that about ONGC. Yes, that is true. You just send me a email at vankar@iitk.ac.in. vankar@iitk, that is IIT Kanpur, iitk.ac.in. You can send me your questions. I'll try to answer as much as I can. How to do protection deprotection chemistry on benzene? What exactly you mean? I don't understand. You have to have a functional group, right? You have to have a functional group on benzene, which you need to get to protect or deprotect. So you ask me specific question. It's very general question. I don't know what you mean by how to do protection chemistry on benzene. For example, what you ask a specific question. I'm not able to understand your question. You ask a specific question. Okay, thank you. I will try. I will try to. I asked you, honey. I asked you to let me know whether this particular course did you get benefited or not, and what are the topics that you would want that are not covered here. You make suggestion since you seem to be interested in having another course. So let me know. Okay. Yeah, I understand that. Yes, that's true. Actually, this particular course which I have offered is for MSc first year students of IIT Kanpur. Yes, IIT Kanpur and um, uh, say MSc students for whom the organic chemistry is compulsory. In a similar fashion, for the organic chemistry compulsory for BSc students, actually the lead tetraacetate favors minimum 2 courses or preferably 3 courses. And that is the reason in this particular course, I tried to do whatever best I could, and try to cover the oxidation, reduction, and CC bond formation, whatever best I thought should be available for the students. And remaining things I plan to do in the next course, or also I plan to write in the book. You can also do as a nitrobenzene. If you do the chlorination, it can go to the meta position, and then do a reduction of the nitro to the amino, and then do a do the orthopara substitution, and later on you remove the chlorine by converting it into a Gilman reagent followed by acid treatment, or there are many other different ways, or by radical means also you can remove. I'm ready to learn organic chemistry more and more. More and more. Okay, now Omkarji, is it okay now to stop, or
Yes, sir.
so maybe you can? If there are no questions, then I think.
Yes, sir. Yes.
Shall I switch it off?
Yes, sir. Please.